Hey there, all you wonderful physics students. Mr. Simon here, creating another YouTube to explain a few phenomena that you see in your everyday world because of refraction. Again, the refraction of light is the bending of light. It happens to all waves, but refraction is most notably seen when we study the waves of light. Here's a common one. I call it the broken soda straw effect. Depending on your perspective, it could appear to be bent or broken. But we see the broken or bent soda straw effect because you're seeing this straw where it really is, and you're seeing an image of the straw where it really isn't. So how is this produced? Well, things in water, because of the refraction of light, always appear closer than the object really is. If you drop a coin in a pool of water, it's going to appear to be inches closer to the surface of the water than it really is. So what's happening? Well, the straw is really here in the glass. And here where I see it through air, there's no refraction. There's no bending because there's no second medium. But in water, it's going to refract. Now there is some glass and it's going to refract because of the medium of glass, but mainly it's going to happen because of the thickness of water. It's going through a couple of inches of water before it comes to my eye. And this is from my nice little Six Flags mug that I got down there years ago with Bugs Bunny on it. Little Great America in the back. Wish we could go again this year, but you know, what are you going to do? So what I'm seeing is an image of the straw. So it's going to be hard to diagram this, and you don't necessarily have to know this. But let's say that I was looking at a point right there, just somewhere in the middle of the water where the straw is. And those light rays are going to come through the water and refract. And they're going to refract away from the normal line because it's going from a more dense medium, water, to a less dense medium, air. And if I were to take a look at a few more light rays coming from there, as it exits the water, again, it's going to refract away from the normal line. So those angles are going to open up. Now imagine that's going to come into my eye. So here's a little side view of my eyeball. And obviously only the light that goes through the pupil is what goes to the retina of my eye, but for the ease of looking at it, the actual light rays are bending as they go from water to air. But my eye does not see that. My eye just sees where they appear to be coming from. So imagine I would extend these two lines and not refract and just have them go straight. They're actually going to hit right there. So again, straight and straight appears to be right there. So the light was really coming from the object there, but when my eye extends those light rays back, it appears to be coming here closer to the medium, or closer to my eye, because of the bending of light through the medium. So hopefully that made a little bit of sense. So anytime you see things bent or distorted in water, or maybe even in glass or plastic, that is more or less the reason why. The other thing I wanted to cover was the waving of light that we often see above a candle flame, or maybe some blacktop or a stove top. We say that we see the light waving and we see the bending of light. What we're really seeing are images because of the refraction of light. So what happens is this. Say looking at a stovetop, and light that's traveling in a straight line refracts dozens of times as it goes across the stovetop. We say that the index of refraction of air is 1. But technically, for air, it's like 1.001 or something like that. And every time you slightly change the temperature, the index of refraction slightly changes. So as you're looking above a stovetop, hot air is rising, cool air is settling in. And as that hot air rises and cool air settles in, the index of refraction is constantly changing because every time you slightly change the temperature, you're slightly changing that value. So here's a light wave that was traveling perfectly straight. It's going to refract dozens of times and it comes into my eye. And the key is the piece of light right behind that. Here's the next light ray coming in a straight line. Using my purple pen here. The air has moved, so the index of refractions of these little pockets of hot and cooler air has changed, so that next piece of light goes through slightly different refractions as it bends across that hot medium and then goes to my eye. So from my eye perspective, I'm seeing heat waving as I'm looking across something that's warm. Again, like blacktop, candle flame, or stove. And technically you're not seeing heat, you can't see heat, you're seeing the refraction of light multiple times because of the heat change above a hot source. The same thing happens for when we look at stars up in the sky. They appear to be twinkling or waving because as light comes into the Earth's atmosphere, every slight change of temperature and pressure changes the little light waves as they come to my eye, and I see the things waving back and forth. I don't know if this is going to work very well, but here's a candle, and if I look across the candle, maybe that little post in my back window, it does appear to be waving or shimmering a little bit. And again, if you can't see that, you've obviously seen this example many times in the normal everyday life. And it's caused by the multiple refraction of light waves as they go across an uneven heated area, such as a stovetop, candle flame, or blacktop. All right, that's a little addition to refraction and some of the weird things that we see in the everyday world. Miss you guys. Hope you're all staying healthy and safe, and have a great day.